James Webb doesn't just take pictures of space. It captures the very beginning of time, revealing secrets hidden for 13 billion years.
Enjoyed this cosmic journey? Smash that like button and subscribe to the 2-Minute Universe for more mind-bending space exploration.
Look up at the night sky. What you are seeing is a profound, beautiful illusion. The stars you look at tonight might not even exist anymore. The light from our nearest stellar neighbor travels for over 4 years to reach your eyes. The light from distant galaxies has been traveling for billions of years. In this vast cosmos, space and time are locked in an inseparable dance. To look deeper into space is to look directly back into time. Every time we peer into the night sky, we are reading ancient history. But for decades, humanity was completely blind to the ultimate beginning. The first stars and galaxies born after the Big Bang were hidden from us, wrapped in an invisible shroud of absolute darkness. The visible light they emitted was stretched across space for over 13 billion years, turning into invisible infrared light. To see them, we had to send a golden time machine into the deep freeze of space. We built the James Webb Space Telescope. Why were we blind for so long? The answer lies in the fabric of reality itself. When the first galaxies formed 13.5 billion years ago, they emitted bright, ultraviolet, and visible light. But the universe is expanding. As this ancient light traveled across the cosmos toward Earth, the expanding space stretched the light waves. Like a rubber band pulled to its absolute limit, the short, visible light waves became long, invisible infrared waves. To human eyes, and even to the legendary Hubble Space Telescope, the dawn of time was a wall of absolute darkness. We were trying to see the invisible. We needed a new kind of eye, an eye that could see heat, an eye that could look into the infrared spectrum and slice through the cosmic fog. To catch the faint, stretched out whispers of the ancient universe, scientists constructed a mirror like no other. A giant 6.5 meter honeycomb made of 18 hexagonal segments of beryllium. Beryllium was chosen because it is incredibly strong, lightweight, and holds its shape in extreme temperatures. But to make it reflective enough to catch cosmic infrared light, engineers coated the entire structure in a layer of pure gold, just a few atoms thick. Gold is the ultimate reflector of infrared light. It bounces 98% of ancient infrared light directly into the telescope's hypersensitive instruments. But looking for infrared light in space is like trying to spot a single firefly next to a massive stadium spotlight. Infrared is heat. Everything that is warm emits infrared radiation, including the telescope itself. If the telescope caught even a fraction of the heat from the sun, the earth, or its own electronics, its cameras would be completely blinded by their own glare. It would be impossible to see the ancient stars. To solve this monumental problem, engineers built a massive 5-layer sun shield the size of a tennis court. Made of a material called Captain, this shield reflects the sun's intense fury, dropping the telescope's temperature to a staggering minus 233 degrees Celsius. Now, let us look directly into the brain of this machine, the advanced cameras that made the impossible possible. Inside the frozen heart of James Webb lie 2 primary instruments of human discovery, NIRCam and MIRI. NIRCam, or the near-infrared camera, is the primary eye of the telescope. It looks at the infrared spectrum closest to visible light. NIRCam is equipped with focal plane arrays of mercury-cadmium telluride, which act like the digital sensors in your smartphone, but are tuned to capture the faintest heat particles from the edge of the universe. When scientists pointed NIRCam at the famous pillars of creation, the results shocked the world. In traditional photos taken by Hubble, the pillars are massive, opaque clouds of dark cosmic dust, hiding whatever lies within. But NIRCam's near-infrared gaze sliced right through the dust as if it weren't even there. Suddenly, the darkness evaporated, revealing a breathtaking cosmic nursery packed with thousands of newborn, brilliant blue stars that had been hidden from humanity for millennia. NIRCam allowed us to peer inside the womb of stellar creation with absolute crystal clarity. Yet, to look even deeper, to the very edge of time, near-infrared was not enough. We needed to see the mid-infrared spectrum. For this, scientists created MIRI, the mid-infrared instrument. MIRI consists of a camera and a spectrograph that captures the glow of cold dust, the building blocks of rocky planets, and the faint thermal signatures of worlds orbiting distant stars. But to detect mid-infrared light, MIRI had to be kept colder than anything else on the telescope. It required a temperature of just 7 Kelvin, which is minus 266 degrees Celsius. That is a mere 7 degrees above absolute zero, the theoretical physical limit where all atomic motion completely stops. To achieve this impossible temperature, MIRI relies on an advanced helium cryocooler, a highly specialized closed-cycle cosmic refrigerator, making it the coldest machine in the known universe. Because of this artificial freeze, MIRI can see the faint, ghostly warmth of the ancient cosmos, capturing molecules and organic chemistry that exist light years away. With NIRCam and MIRI working together, James Webb turned its cold, golden eye toward a tiny, seemingly empty patch of the sky. A patch the size of a single grain of sand held at arm's length by someone standing on Earth. It stared into that darkness for hours, and when the data came back, it revealed thousands of massive galaxies in a single image. This was Webb's first deep field. But as astronomers began to analyze the data sent by the cameras, panic began to set in across the scientific community. According to established cosmological models and standard timelines, the early universe after the Big Bang was a chaotic, unorganized place. It was supposed to take hundreds of millions of years, if not billions, for gravity to slowly pull matter together to form the very first galaxies. These early galaxies were expected to be small, messy, dim, and completely unorganized. Instead, James Webb's cameras saw massive, highly structured, brilliant galaxies existing just 300 million years after the birth of time. They were too big. They were too mature. According to our current laws of physics and standard evolutionary theories of the universe, they simply shouldn't have existed. The data sent shockwaves through universities worldwide. Some sensational headlines even claimed that the Big Bang Theory was completely broken. While the Big Bang itself remains intact, Webb's cameras have forced us to completely rewrite our textbooks about how the universe grew up. The cosmos was much faster, much more efficient, and far more creative at manufacturing stars and galaxies than we ever imagined. We used to think of cameras as simple tools to capture a fleeting moment in our present lives. A photograph freezes a second of our existence, keeping it alive forever in history. But the cameras aboard the James Webb Space Telescope do the exact opposite. They capture a past that died billions of years ago, bringing it to life in our present. Every stunning, colorful image produced by Webb is a cosmic ghost story. The stars we are looking at in those deep field images may have exploded, collapsed, and vanished into black holes eons ago. Yet, their light is just now arriving at our doorstep. We built a machine, wrapped it in gold, froze it to the brink of absolute death, and sent it into the lonely deep space. And in return, it gave us our own origin story. By looking through the infrared eyes of James Webb, humanity is doing something truly profound. We are the universe, opening its eyes, looking back through time, and observing its own birth. As we stare into that ancient golden mirror, we realize that the story of the cosmos is no longer a mystery hidden in the dark. It is a story written in light, and we have finally learned how to read it. We are no longer just observers of the night sky. We are the historians of time itself, watching the universe create the very atoms that now flow through our veins